Hi there, welcome back to the DevOl. I am Roman and today I'm going to try something different. This is not a video that I'm editing the hell out of it and taking out all the amps and mess ups and everything. You see, I was just motivated by seeing some guy on Twitter, Ryan Florence, pretty cool guy, who made a game. It's called Tense. He made it to try something out, but I was motivated to try it out in the Elmish architecture and how this would work out. So this is basically me trying to build this thing from scratch, messing up all the time in the meantime, introducing a lot of bugs and ranting about some things. So something different. I guess it got pretty long. It's maybe 1.5 hours. I'm not editing out too much. If you like to stay to the end, I got a delivery during the recording of this session, which are some new shoes, and I'm going to do my first unboxing video ever of my new white Zenmotic shoes. So stay there to the end. If you have any questions, just put them down there. If you want to discuss anything, just ask me whatever you like. Give me a like, a subscribe, and if you want to support this channel, go to my Ko-fi page, buy me a coffee. So without further ado, los geht's! Alright, should we try this? This is going to be hard for me because I just keep going. If I mess up, if I tell some bullshit, I just keep going. Let's try if this works out. So we are going to build, or we are going to try to build this game here, Tense. So Tense is a game, so where some numbers are going to show up on the screen, and we need 2 or 3 numbers that equals to 10 when we add them up. If they are over 10, we have lost, and if we are 3 and they are under 10, it's a game over. And if 10 numbers are displayed without clearing anyone out, it's also game over. So I show you how it works. If you're a bit confused, I was in the beginning as well, but I think it's a really nice and funny game. Makes a lot of fun actually. So we get this number here played every seconds or something, and then we can actually click on some numbers. It's the number that I've clicked on is not shown, and I have 0 points here. So again, I click on the number, the 2, for example, and then I wait for an 8, and 8 plus 2 is 10, so I click on them, I get the score of 1. Then I have the 9 and the 1 and the 4, 5, 1, and so on and so on. And if I have 3 numbers and they're not equal to 10, I have also lost. So this is what we are going to build, or this is what we're going to try to build with Elmish. So let's start this. So whenever I'm building something like this for trying it out, I think it's a good place to start is the Elmish starter pack by Zaid. So let's do this here as well. Elmish starter Zaid. Look how often I have already searched for this. We can use this. We can clone or download it here. And then I open this already in my path and I say git clone this thing here. Oh, already exists, of course. So we call this Tense then. So now we're cloning this into Tense, and we go into Tense. Nice. And then we can actually run npm install. If we could write, it's a bit strange with the mic here. Let's see how this will work out. So we install this, and it will take some time, I guess. So in the meantime, we can already open this folder. So in here, you're not seeing this, but I can just open the Tense ordner in here. And I hope that we will see this. It seems every time I'm recording or I'm streaming, it seems that my computer gets slowed down a bit, but it should be all right, I hope. Okay, let's see how far we are here. It was installed. A lot of stuff was cached already, so it should be fine, I hope. So if we have a look here, we have our app, and it's a typical Elmish app with the counter. So if we are opening the console from here, so we can see if there are any problems. Oh no, let's not do this from here. Maybe this screen state is not enough. Just let us open the console from here, and we say npm start. And then it should compile all the stuff, and hopefully we should get a project running on localhost 8080. I'm waiting a bit, and then we can already really strange here. Oh, how does this work here? Anyway, we can already open the 8080 port. Oh, and we see that the counter is already there. So we have an increment, we have a decrement, and everything works as usual. But enough with the counter. I think you have seen a couple of them in your lifetime. So I'm not going to explain any Elmish here, I think at least, because we want to build this game. So let's have a look at the game again. Where do I have it? I have a couple of things open here. So we have this 10s game here. So again, we have a score, we have things that pop up, buttons that pop up with some random numbers in there, and we need to be able to click on them to be able to reach 10. So we need to think of our game. How can we actually model this in our Elmish application? So what I always like to do first is start with the types. So where do we start? So maybe I'm starting with some modules and not with the type. So let's just make a module here, for example, for state. And this module gets the init and the update function. And then we can have a module here for view. Can do this however you like, but I like having this actually in models in our application. So, but of course we have a problem in here directly. Oh, it's not a type. It's a module, of course, because I'm stupid. All right, everything looks good. And also here I put in type. Man, this starts really well for me. Okay, and then we need to say, okay, we want to have the state in it, and we have this state.update function that we put in our program, and we have the view.render function. Cool. So save this. Everything should still work. Perfect. Okay, so now let's think of our application. So we have an application, we have a game, and I think the game can basically be in 3 states, right? So we have, if we're opening this again here, we see this is basically the starting screen. So the game has not started yet. Then we are in a game. And at some point we always lose, so I'd say let's just we have finished the game then. Okay, so this is what I would make my types with, and I would then say, okay, then let's just do this here and say, okay, the state is the discriminated union. It's not a record, and it's game not started. Then we have the running, and we have finished. I'm thinking of this. I'm just not using game here. So we have the state of our application of our game can be not started, running, and finished. So, and then let's think of the messages. So what can happen in a game? I think I have clicked on some number, maybe. We'll see later on how we're actually managing the clicks on numbers. So then we have a new number. And this needs to be a number then. So this is when a new number comes in. And then we have something like start game. And for example, we have something like... Just go with this and see how this will work out. So if we are in the running state, so maybe if we are in the finished state, we need to actually have some points. So we need to have our score in there. So I'd say that in the finished state, we also need this finished thing. And what do we need while we are running? I'd say we need, let's see, what do we need? Let's call this running. So there is a specific state for running, and I'd say we have the score, current score, which is an int. We have the numbers that are shown, which is a list of an int, of ints, and we have, what do we need? We need to somehow keep track which numbers I have already clicked. So if I start this again, we see here we get the numbers, and if I click on something, the game needs to remember this, right? So the game needs to remember that I clicked on 1 and 7. So there's another, oh, I was too late. But the game needs to remember on which numbers I have actually clicked, so that this actually works out. And it needs to keep track of the score, and we need all the numbers in here. So let's do this. We also have clicked, which is also a list of ints, I say. Or is this just an int? So can we just, maybe we can just use an int in here, because we only need to count, let me think. We only need to count the numbers that are added up. No, it's not like, right? No, we need a list, because otherwise we don't know how many numbers we have clicked. So on how many buttons we have clicked. Because if we just add this up, we have lost the information on how many things we have clicked. Nice. So, and then this will be then the state of our running state. If you ask yourself why I'm doing it like this, I pretty much doing it all the times like this, because I don't want to have this thing in my state if I have not already started, for example, my game. I really don't want this, because then it's again this topic of making illegal states unrepresentable. And so what would be the numbers clicked in case the game is not started? It's an empty list, but it doesn't really make sense in the case of not started. So I'd say this can only be possible if the game is already running, so we can actually put this in there. So when we are starting, we can then say, okay, we have a not started state. So this is how we are going to start this thing. Okay, then we need to build our update function. Let's do this. We have our update function. So which messages do we have? We say we have clicked, we have new number, and we have start. Let's just make it like this and think of this maybe a bit later, because there we need to put all the game rules in, right? So in our just normal case, we can't really click anything. we just return the state. So to make it runnable at some point. And then we need to build our view function. And to be honest, except for the streams, I have never really worked with Felice. So I prepared this thing here so that I opened the documentation of Felice just to have a quick view over it, how the syntax actually works. Yeah, we have some responsive issues here, but I don't think that it will make some problems for us. So I think the documentation is actually pretty cool. They put a lot of work into this. So let's actually make use of this. So we have the installation. We don't need this because the starter pack is already installed, and we don't need the template in here. But if we have a look at the syntax, I think this is what we are actually needing. So let me just check something. Yes. Just needed to check if I'm actually recording. Because this is what I forgot sometimes. Okay, so how can we actually use this? So we have this HTML prefix all the time, the module, and then we can say .h1. And as far as I understood Said, he put in a lot of overloads so that we can use it pretty much however we want it. So if we only have a simple div, we have just a div function that just takes a string. So this is possible, but because in the normal React, Elmish React syntax, we need to always use those brackets here, those child list elements. So this is basically this then here. We have an HTML div, and it has, in this case, just one child, which is the h1. And we also can just put a lot of those things in there. And if we needed properties or attributes for our elements, we actually need or we can do the class name and the children, but we can't mix and match. I think this is what he's saying here. Yeah, that you can't mix attributes and child elements. So if we only have child elements, we can put them in here. But if we only want to have attributes, we also need this one here. So, and then we need the children syntax. But I think this is pretty simple, and I like this. So let's just use this. Okay, so we have this render thing here. And the nice thing in here with our state, let me just check, we have 3 cases. So we have not started, running, and finished. I think I will not delete this because I can use the buttons later. So we have not started. In this case, we do something. Let's say, call this render not started. And then we have the running, which gives us our running state. And then we have, and then we have here render running, which also takes the state, or which takes the state because we need to actually show it. And then here we have the finished with the score. Oopala. And then we can actually say render finished. And we give it the score. Okay, nice. So this is what I like to do. I just start with the basic like scaffolding of a new program, and then later on I fill it with some logic just to have the basic structure of the program. But of course I deleted something here. So we say match the current state with, and then this will work out. Okay. That's it basically for this. So then let's build the render not started. So let's actually make this compile so that we can work maybe on the buttons or something. So we have let, I like to use private then to make it clear that only the render function is the only entry point for my view module. So I say let render not started. Does this get anything? I'm not sure. Oh yeah, we need something, of course. So in here we have a html.div, and this one takes pretty much this here, right? It takes as one child element, one button, and it says start game. And in order to be able to start a game, we also need to feed the dispatcher in here so that we can actually send some messages. And then we say start game. Nice. So now here we also need to put the dispatcher into this function. Okay. So let's first of all make this compile. Let private render running. And this also needs the dispatcher, because otherwise we can't send any messages, of course. And then we put here a HTML div where we just say running. And then we have the let render finished, where we put the score in. Yes, and maybe also the dispatcher, because we want to restart the game later on, right? So we say then here HTML div finished. Nice. So here we need to put the dispatcher in there, otherwise it won't work. Oopala. And also here. Cool, and then we don't really need this anymore. So now we should have a working application again with the start game, but nothing is changing really because we don't have the update function yet. So let's make maybe the game a bit bigger. How can we actually do this? Let's see. React API support type safe. Do we need CSS? I don't want to use CSS because I'm not good in CSS. Yes, let's use this. This looks good. So what do we want? Just make it a bit bigger. It's not, it won't be very clean, I guess, but just make it a bit bigger. So what was this? It was called props style. Okay, I can do this. So we say, maybe put this up here, props.style, prop.style, and then what do we want? We want a button that is maybe style.font size, I don't know, 12. Doesn't change anything. Look how good I am in this. 20, much nicer. And then maybe we give it a padding. Also 20 maybe. Oh, nice. So we have a real start button there with the start game. I don't put the game rules in there. It's just, no, let's just build the game. So when we are actually starting the game, what are we going to do? So we have a start. And then we need to return the running state, right? Running, and we need to initialize this record. So what do we have in there? Score, numbers, and clicked. So we have score equals 0, numbers equals an empty list, and clicked equals an empty list. So this should work, I hope. So when I click on this, yes, we are actually running. Nice. Okay. Where are we going from here? Let me think. We are running, so maybe let's try to actually build. Let's try to display some buttons. So maybe we can say we have the numbers in here, and we could just initialize this with 1, 3, 4, 1, 2, 1, 3, 4, whatever. And now if we are clicking on the game, we want to actually show the buttons. So we have this render running in here, and we have the div. So let me think, what could we put in here? I'm not using those four in loops, but Slate is using them a lot for those one-liners. Should I try them out? I'm not sure. Let's just try them out. So for number in state dot numbers, we want to actually render a number button, and it takes the number, and it also takes the dispatch, because we need to be able to make it clear that we have clicked on it. So if we are building this, we have the let private render number button, which takes the number and the dispatcher. And this thing is also just a button. So I'm copy pasting this here. And then we have here the prop text will be a number. So I say string, maybe number. Unique overload could not be found. Okay, so there is overloads for text. So I could say number. And then we have unique overload could not be found. Okay, because it doesn't know the type of number. So let's try if this will work. Ha! This is actually really cool. So there is an overload for the text function, or method in this case, I guess, because otherwise we wouldn't have an overload, which can either take a number or an int or a string. Nice. This is really cool. So we don't need to cast our stuff to be in string. This is actually pretty cool. So, and now we need to dispatch the clicked method. And the thing is now, where do we click on? On what? Let's think of this in a second. But now if we have this, actually, let me just check. Oh, nice. We have those buttons here, also with the padding, and we can actually do something, but I need to click on it. And the question is now, thinking of this, we can't really put the number in there, right? Because if we then try to find the number, we don't know which one to actually get rid of, because if we have a look at the tens here, let's see if there are two numbers the same. Of course not. Now here. And if I click on the 4, it's not this 4 that goes away. It's the specific 4 that goes away. So we need to know on which specific index of the list we clicked, I guess. So we can't really do this, because I don't think that we get the index in those 4 lists and these 4 loops here. So they're not called for loops. What's the name for those? I don't know. So we need to use a map I guess. So we have the state numbers, state.numbers. And we want to pipe this into list map I. So then we need the index, and we have the number, and then we can actually put this into render number button index number dispatch. So I get rid of this. And this is not working because, of course, this is a list of a list. So what do we do in here? I just use the yield bang, so I can put a list in there. Let's see. But we have the render number button, and of course this is not what we want, because we have the index in here. And I guess we also need to make clear that this is also an... No, we don't need this. We can say it's the index, because we don't want to actually show the index, right? So if we do this, and we use this clicked in here, so here we also need an index then, of course. Clicked of index. We just give this printf index index, and then we return state. Nice. So what can we do here? Error while compiling. The dispatch is wrong. What is your problem? The type int message does not type message. Oh, of course, because in here we then also need to put the index in there, and then it should actually not work. What is your problem? We have the clicked of int, we have the clicked index. I'm a bit blind at the moment. We say render number I. Oh. So this should clean it up. So because it was thinking that dispatch is a function that takes a message and an int. And this is not what we want. We want to put a message into the dispatch function, and otherwise it won't work. So if I start on this and I click, we have here index 1 is clicked. That's correct. Index 0 is clicked. Index 3 is clicked. Nice. So seeing this here, this can be cleaned up. So if we actually switch the arguments and make them more map I compatible, we can put the dispatcher up first, then we can get rid of all of this, and we can use partial application. So we just say, okay, we map over it with the map I function, and we partially apply the dispatcher into it, and then we don't need the lambda. I think this is much nicer. Okay. let's keep going. So we clicked on the numbers. So what do we want to do now? We want to actually now can we already implement some logic in here? I'm not sure. Yes, I think we can. So how can we actually work with this? What we need to do, I guess, is we have those numbers in our state and we have the index. So we need to find the index. And let's just see what F# has. And I think there is something in the list func module. Let's just find index is not what we want, I guess, because it returns the index as far as I know. Try find returns the first element. No, this is also not what we want. Let's go through this. Count exists in find back. Normally I'm not using something like this item. The index to retrieve list, the input list. This is basically what we need, right? The index of the list, then we get an item back. But it throws an exception. This is not what we want. So let's check if there is a try version. Try item. Tries to find the nth element in the list. Returns none if index is negative or the list does not contain enough elements. Thank you very much. So we have our state. So, but our state is actually our discriminated union, and this is not really what we want, right? Because now I needed to match over my state in here. I needed to say match state with blah, blah, blah. And this is not what we want because we don't want to have this in every message. So what I'm doing in those cases then is I'm matching over a tuple in German, tuple. And then we can say, okay, only if we are in not started, the start method actually makes sense. So we only use this here. And then here we say, okay, only if we are in the running state, then we can actually click on an index. And in all other cases, just return the state for now. So then we can say, okay, the state numbers, and we want to say list try item, and we want to find this index. And what we get back is an option, and we only want to work with it, I guess. We only want to do something is if we actually find an item. So we say option map. And then we have actually found the number that we are working with, right? So if we do this, then we need, in the end, if we need to use option map and we need to return something that is not an option, we always use default value, and our default value would be just the state. So we have this here. I put this printf to the top, and I don't need this. So in this case, we do something with the number only if we have it. And in this case here, we just need to work with this, right? Okay, so we have found the numbers now. So let's say we have a new state because we want to create a new one, right? And this new state is what? Let's indent this a bit more here, maybe. We can clean this up later, not to have this this lambda in here, because I guess this is one where we get pretty big, right? Because this is where the game logic needs to reside in. So we have a new state, which is basically what? We get also the score. No, we don't need to change the score for now. We want to have clicked equals the number. It's strange writing this like when I know I'm recorded. A lot of stuff is missing then in my head. Okay, we just want to change the record, right? So, and then we say, okay, clicked is we want to add this number to the list of clicked. So this is then state.clicked, basically, right? So this is this. So now we have the new state and we put this clicked in there. So let us just check if everything works. So we return the new state in this case. And maybe we need, yeah, let's put the running in here. And if something goes wrong, we need to check this here if we are finished from that state on. So, and then let's implement some helpers for us, or let's use them. We have this with console trace, so we see all the states of our application. So we have the initial state, which is not started. And I say here, now we have the new message start, we have the updated state running. And if I click on a function, on a button, we have the running, and this is not really readable. No, let's change this. I can clean this up here for first, and then maybe here we say, okay, in the render running, we also get the yield. How did you do it? It was just html.div. And we need to put a string in there. So we say sprint f a with the state. So this should be nicer. Okay, now we see here the things. And if we click on something, we see, that's much better. We see that we are actually changing the clicked link. Okay. Now we have done this. Let's see. Now we need some rules, right? We can actually... So first of all, we need to remove the one that we have clicked on. How can we do this? Is there something like remove an index from a list? I don't think so. No, I don't think though. There isn't. I think I at some point built something like this. So how was it? Let me think. So we want to remove the item at a specific point. So we say we have remove index at maybe, and we put the index in here and the list. And then we say we take the list, we use again list map I, we have the index and the element, and what we are returning is basically a tupled version of this. A tupled version of this. And then we can say, okay, list dot filter. And we get also here the index and the element. And then we can say, okay, I only want to keep those where the index is not equal to the index that I want to filter out. And then I can say list map again. And I only want to have the second part of the tuple. So this is the helper function for the second part of the tuple, right? Is this good? We can make it a bit differently also. We could say, oh, we could also, let's make it like this. We put the comparison in here. That's nicer. We put the comparison in here. And then we can actually say, no, I want to filter on the first. So the first part of the tuple is the Boolean if it's not the index that we want to get rid of. And then we filter for the first part. So if the first part is true, which is this Boolean comparison here, then we keep it in the list, and otherwise we throw it out. And in the end, we just take the second part again, and we have the list with our elements backed. So the number would be then numbers equals to state dot numbers remove index add index. Okay, and the nice thing is we can do this, and we can be sure that everything is there because we use here try item and then we say option map. So only if we actually found something, we can work with this. So we don't need to keep track of this somewhere else. So if I click on this, it looks good. Yes. So we get rid of the numbers. Of course, we need to reload this then because I really get rid of those. Nice. So I'd say we can build some game logic now. Maybe I put some more in here. 5, 8. Well, let's keep it like this. Okay. So what is our game logic saying? So let's check out the rules again. The rules were, if we have 2 or 3 numbers that are over 10, it's game over. If we have 3 and there are under 10, it's game over. Okay. And otherwise, we can keep going. So if 10 numbers are displayed, that this is when we later come to the point that we can actually get some new numbers in there. So we don't need to take care of this now. So let me think. So we say if new state so what do we want to do? If new state dot clicked, if those list dot sum equals 10, then we don't need this. Then we have reached our goal. And we say then that we can actually say, okay, we have running. But for now, we have new state with score equals score plus 1. Okay, so we need to add 1 to our score, and we also need to reset the clicked, because otherwise we would lose in the next round. So if it's 10, it's like a reset for our for our game. Okay. Else if, so if now, if the new state dot clicked now list dot length equal 3, then we have lost, right? Because we have checked if it's 10, it's not 10, and we have clicked 3, so this is not allowed. So then we can say, okay, we have finished, and we say the points is new state dot score. And in all other cases, we just say running. So we just keep going with the new state that we have just created. And the score is not working here, of course. And we are returning this new state, and we don't want this. Okay, let's recheck this. So if the new state, so if we have clicked a total number of 10, then we just add 1 to our score and we reset the clicked part. If our clicked list equals 3, which means we didn't reach 10, but we have 3 clicked, we have lost, and we finished the game. And in all other cases, we take the new state with the new clicked, and everything is good. So if we have the finished with the score, did we already put this in here? No, of course not. So let's just say here, sprint f finished or score equals score. And see, so we say we have 8, 1, 1. Our score goes up and the clicked is resetted. If we have 4, 4, 5, we have a score of 1. Yay! So the basic game logic works, I guess. It's not the nicest and the most clean thing yet, but I think we can actually make this work out later in a nicer way. So I think maybe we could introduce a restart thing here. Yeah, let's do this. So we have a restart, so we need the list here, and we just copy a button again. Just to make this clear, this is basically me trying to invent something on the fly. Of course, if I would actually build something with a team, we would put a lot more emphasis on the model up front and think of all the cases up front. But I'm trying to build this here, and we would also think of, extracting functions, don't repeat ourselves too much. But I just want to make this work here and show you what the basic way of building these things would look like. So now in here we have the div. We say maybe HTML span, or let's also make a div in here. And then we have also the button as a child. The text is restart. We have the dispatch. We also want to restart the game. That's it basically. Now we don't have a restart message. Let's build this also into our messages. And then we can actually say, okay, if we are finished with some points that we don't care about, we can actually restart the game. And what this means, we can basically copy this in here, and maybe then I can already take this out and say let private initialized game. I think this will come in handy later when we have like not some dummy data in here, but we need to have some constructor for our game anyway. So we have the initialized game in here, and we have also this in here to be able to restart a game. So let's see if this works. One warm up, score 0, we have restart, yay, it works. So this is nice, and you see a small new feature was done pretty easily now. Let me just get something to drink. Okay. So now let's come to the hard part, I guess. So how do we get the numbers into our game? Like each second a new random number. So we need some random number generator. I think we just use system random from the .NET library or framework. But we need to think of how we can actually get those numbers into our system within the Elmish architecture. So I prepared this, to be honest, because I was thinking about this, and for me, there is not really a nice way of doing this yet in Elmish. So I wish there was something like real Elm subscriptions in Elmish, and there is an open issue. I'm going to show you this. Let's have a look if I can find it. Elmish. Nice. So our streams 8, nice. Our streams are the first 3 videos we see. I see at least if I'm looking for Elmish on YouTube on Google. But I want to go to the repository. It's here. And if we go to the issues, there is one I created half a year ago, which had different topic at first. Anyway, don't want to go into this now. It was a long conversation. But at some point, there was the discussion if Elmish subscriptions are similar to Elm subscriptions, and I think they are not. And I really wish that they were like this, and now I could make a pull request, but I really don't have the time at the moment. So as a homework, do this. You would make me very happy. So the thing is, if you have a look at this, this is Ellie. No. Terms of service, I accept, of course. So we have this Ellie thing here. It's basically the REPL of for Elm, the REPL of F# for Elm, or Fable REPL. And in here we have also subscriptions. And the nice thing about Elm subscriptions is that they are called for every update call, which means, and they get the current state, so in this case here it's model, in there. And this is pretty cool because this is basically what we want to have in our application, right? Every 1000 milliseconds, we want to send a message into the update function, which is in this case the tick message. But we are going to do this based on the current state of the model. So if we have this subscription, which is a clock, and it counts every second. And if I switch this off, you see that it stops, because here in the else case in Elm, we return a subscription none. So the Elm runtime actually keeps track of all the subscriptions that we are subscribed to, like WebSockets or this time thing, and it checks if it's already there, and then it's not restarting the timer, for example, which is pretty nice and needed if we need something like this. And this allows us to actually have subscriptions based on the current state of the model. So I can switch this on again, and then we see here, okay, the time has changed because it uses a command or a task then later to actually get the time. But the ticking one is then restarted. And this is basically not at all possible in Elmish. We need other ways to do it. And it's possible to have, for example, a specific React component that has a unmount and on-component mount and on-component dismount thing in there that is then sending the messages, but it's all not very clear. There is Elmish Streams by Doug, which is an awesome library, I guess, but due to some reasons, we can't really use this with Elmish at the moment, or not with the standard Elmish at least. So I can't really use this for that case, and I would love to have this subscription based on the current state of the model, but this is just not possible. So we are using basically something different, and we are using JavaScript for this. So there is this one thing here. I asked Said if he had something available, and there is this one thing here what we are using. So I just copy paste this basically, and I will explain in a second what it is doing. So I will make maybe here a module, maybe extensions. And I will put those two functions in here. We need to open something from Fable, I guess, to make this work. Open Fable, no, open Fable core. Yes. So now we have the emit and the JS native thing available. So what we are doing now, we're using the native JavaScript functions clear interval and set interval. So for set interval, it takes a function that takes unit and returns unit. So it's a pure side effect, something that should happen every n milliseconds. And it returns an integer. And this integer is basically used to get hold of this interval, so that we later on can actually use the clear interval function. And here we need to put the n in, so that JavaScript is actually clearing the interval for us. So it uses then JS native. So this is the syntax in Fable to have JS native FFI interface. And here we say, okay, we emit that if we call set interval, we are actually calling this JavaScript function, and this is the first parameter, that is this function, and this is the second parameter. This is then the milliseconds. And then we can actually use this. So what is he doing here is then he has some, let me see here, start ticking and stop ticking thing. And yeah, I think we're basically stealing this, but maybe in a different way, because what he's doing here, he has a tick ID is an option of an int, but I don't want to work with an option for this. What I would like to do, let's see if we can make this work. I would like to do in here, so we have a start ticking function, and this start ticking function returns a function that takes a dispatcher and returns unit. This is basically to create a command in Elmish. So if you have no clue what I'm just talking about, maybe you could watch our introductions, 8 and 9 introductions into Elmish, because this is where we're basically explaining all this. So then in here we say, okay, we get the tick ID, and then we have the set tick ID with the some tick ID. Let me just check this later, and maybe this is then here. Let stop ticking. And this needs to get the tick ID. And then we also return a dispatcher function. Or in the end, we are returning. So maybe this should be the first thing we are actually doing. And to be able to access all this, we can open the extensions module. Then we have this. Oh, and we also need to call this start here, so then that I can actually create this thing in here. Okay, so this is basically start ticking and stop ticking. But what I would like to do, I don't want to work with a global or with a always available optional thing in our state. What I would like to do, I'd say the tick can only occur if the game is actually running. So maybe in here I can put a tick ID, which is an int. And then we can actually use this here. So for now, I put the tick ID in here, which is 0, and we will make this work in a second. So let's think this through. How should this work? So I want to click on the start button, right? Or restart button, whatever. And when I click on this button, I want that then the ticking is actually starting, so that every second we get a new random number in there. So how can we do this? What, maybe like this. In the case that, in this case here, we want to actually return a command that the game should start. So if we want to do this, I think we need to change our structure now pretty drastically, because now we need to start to actually work with commands, right? Because this is a side effect here and we need to work with commands. So what I would like to do actually then is something like, I would have a message, and this message is like game started, for example. And in here, we get the tick ID. So then we could actually use our initialize game in here with the tick ID to be able to close it later, and we can put this in here. Now we need a new function that is called a new message case that is called game started with the tick ID. And what we want to return in here is that we have the running with an initialized game with the tick ID. Okay, and in those cases here, in those two cases, what we actually want to do is we want to return the state. We want to return the state, and we want to return a command that is actually start the game, right? So this is the game that we are actually want to do in here. So here we also need to, this not started, and of course it's not an equal. It is like this. So first of all, now we need commands. So let's actually switch our program from make simple program to make program. And in those cases, now we need to, of course, to actually change our init function. So now we have here a command .none. And we need to return our update function. So everywhere here, we want to return command.none. So in all cases. So this means here and here and here and here and here. I think we can clean this up later. And now we are not just returning the state, but the state and the command. So we can get rid of those and use here the type inference. Much nicer. Okay, but now we need the start game command. And I think we already have this here. It's not start ticking anymore. So it's start game. And start game sets the interval, dispatches a message. We'll come to this in a second. And then we say, okay, game started. And we don't need the option of the tick ID yet. This is how we can do this. And then we can actually work like this. And if we stop the game, or stop ticking in this case, we can then just clear the interval. And we don't need to return a message, I guess. So it's just a dispatcher function returning unit. And we don't need this here then, but we can put this in there. So we have a function that takes a dispatcher, but it doesn't really matter because we only want to have the side effect of clearing the interval. So now in here, we need to send the message of the function or of the new number. So we have a, what is the message called? New number. So we called it new number. Let's make this maybe. So we have the message. Oh, yeah, we have a number which is 0, for example, and then we say we dispatch new number with this number. So does this make sense? Somehow? I hope. Does it make sense for me? Yes, I hope so. I think so. Okay, but now we need to create this number. Yes. And this is another thing. This wouldn't work in Elm, but we are in F# and Fable, so we can use side effects at any time. I'm also not really fond of this, but I'm just, for the sake of the time, doing this now. So we have something like random. So we have another global state, basically, where we say, okay, this is system.random. And now we can say the number in here is random dot next between 0 and 9. So now we should get a new number every second. So why I don't like this, and the reason for this is that normally in Elm or in the Elm application architecture, you want the state of your whole application to be at one place, right? And what we are doing now is we have this global set interval and clear interval things here, and we have this global, pretty much global random number generator that is also sitting there. And normally I want to have also all the side effects just in my runtime. And now I have those side effects of this random number generator in here. Yeah, if we would build a bigger application, I would like encapsulate this a bit more and trying to have this all in the runtime. But let's keep it like this for now, or for this video, I guess. So let's go through this again. How does this work, or how should it work? Let's just check if it's working. So we have this, and it's not working. Of course, why? It's not working because we're not doing anything with those numbers, right? Let me just show the console. Clear it. But we see that at least we get a new number every second. This is nice. So let's do something with it then, with the new number. Okay. So in this case, we also only get a new number. We only get the new number if the game is running and we have some state and we have a new number, and here we have the number. And what we want to return for now is again running with state with numbers equals state dot numbers, and we want to put the new number in the end, so we can use this operator here and put this into a list and say, okay, we concatenate those two lists. And if I could write, this could actually work. Well, and of course, we also need a command none to return this thing. So, and this is not number, but numbers. And now I hope that everything works. So we have this here, and we see, nice, that we get the new numbers in there. But what do we get in here? We only get the ones. What did I do wrong? Let me check. Okay, this shouldn't be a problem in here. What did I do wrong? But, oh, okay, what is different now? So it's, man, so, sometimes I'm really stupid. I think most of you have already found the error, right? So what I'm doing here is I'm generating the number up here, but then we are calling this function every time the interval hits. So we only take the same number. So we need to inline this here, of course. So then it should actually work. So we have this function. So maybe call it like this. Oop. That's a bit more readable. So then we say here this set interval thing, and we put the, let's call it callback. Have this in here. Okay. Yes. Typical error. Let me just change this here. I don't think we need this function, so we can re-indent a bit. Do it like this. Okay. Nice. So I hope now it will work. 5, 5, 4, 2. Yes, now we get our random stuff in there, but we don't have the game logic completely fleshed out. But yeah, this is working now. Bit embarrassing, but yeah, that's how it goes. Especially because I'm getting a bit tired, I think. Okay, so again, how does this whole thing work? Let's just go quickly over this so everyone is on the same page. So what do we have? We have here, in the case that we are not started or finished, and we use the start or restart message respectively, we just return the state now, and then we return a start game command. This start game command then uses a function or creates a command in here, which is actually internally starting an interval, and each interval we set a new number, and before everything is really kicked off, we dispatch the game started message with the tick ID, and then we get here, in our cases, the game started with the tick ID, and then we can actually say that we are running the game now with a new initialized game and the tick ID. So now we can actually get rid of those dummy data thing here, and we can use the real game. Let me see if this works. So we have here all the numbers, 4 and 6 and 8 and 1, and now I'm hoping for another 1. And there is no 1. So I think I'm going to lose. There was the 1, but let's just finish this game in here. And oh no, we're not finishing it, right? Because we didn't really put all our game logic in here. So in this case, what are we going to do? Well, in this case, we say, okay, we have let new state equals this state in here. And then we say, okay, if the new state dot numbers on the list of this state equals 10, then we have actually lost. So we say finished, new state or state, doesn't really matter, new state dot score. And then we don't want to send a command in there, so we use this. And in all other cases, we can say no, we are still running with the new state. And of course, again here, we don't want any commands in there. So let's check. So make this a bit smaller here, maybe this list, so that we can check if our 1, 2, 3, yes. So if the third one was should be displayed on the table or on the screen, the game is actually finished. So now we want to restart the game, which is not working. Why is this? Oh yeah, of course, because we say, okay, we only go into the running state if the state was not started. We didn't go from finished and restart. So can we actually do this? I don't know. We have not start or finished. With some number in there that I don't care about. And now let's check if this is working. Yes, and then we can say restart, and we can actually restart our game. Nice. Cool, but this looks a bit strange. Why is this the case? Let me just put this to, well, let's just clean this up. Oh, of course, yes. We didn't clean or stop ticking here. We didn't clean the game up, right? So what do we need to do? We need to go to the states where we actually say finished. So we have this and this one here. And there we need to send the command to actually stop ticking. And we want the ticking is the new state tick ID. And if we are doing this, we should actually stop the ticking to be able, where was the other one? To be able to have a nice new game at the beginning. So let's see, 1, 2, 3, it was restarted. No new messages are coming in. And then, nice. Everything restarts from the start. Cool. So then we can return this here to 10. And I think we're done. What do you think? We have start the game. We have 1, 2, doop, 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 doop. We can play with it. We have 3, 3, 4, 8, 1, 1, 4, 6. We'll let it run out and we have a score of 3 and we can actually restart the game. Nice. Okay, so basically the game works, but it's ugly as hell, right? So what I would like to do now and to wrap all this stuff up is to clean this up here a bit, because what I really don't like, I think the update, the view function is fine. We could take some buttons out of here or do something with it, but basically it's fine, I'd say. What I don't like is the update function, because this is for me basically the opposite of declarative programming. So here we can't really see, this should happen, and then this should happen, and then that should happen. We really need to go through all of this, and then we have a big, huge lambda in here. And this is what I don't really like, actually. So I'd say let's wrap this up, cleaning this up, so that actually someone who comes in later, or maybe me or you in 2 weeks or 2 months, can actually understand what is going on in here. So where do we start? The first thing that I always like to do, and I put this now in the state module, but you can put this pretty much everywhere. We have this when we are for our production code. We have this in some Elmish extensions module. Is what I like to do is that we can actually have a function that is called without commands. And in this function, we can pipe the state, and what it returns is a command of none. So then we have here the state in here. And the nice thing is then now we can actually, so my goal is always to have it like declaratively and readable. So what we can do now is we can take this without commands, and everywhere where we are finding here command none, we can go through all of the occurrences, and we can replace this by piping this into without commands. So for me, this is really nice. I hope it gets nicer a bit later on, but we can always see, okay, in here, if something else happens, we return a state without commands. Or here, we return the new state without commands. So what else can we do? As you've just seen, when we are finishing a game, we need to think of using this command that actually stops the ticking, right? So this is a perfect case for me where we can actually refactor this into a function. And we could call this maybe let finished game. And we put the state in here. And what we can actually do is we can use those tuples and put this in there. So then we can replace all this with finished game and the state. And now if we have a new feature or something, or we rearrange the code, we can actually just use this finished games thing, similar to the initialized game. We can get rid of this one here. I'd also like sometimes to do it like this, that I say, okay, we have the initialized game, and this is then running without commands. So in this cases, it's just a nice way of actually reading what should happen in my system. So then I can get rid of the braces here, which is nice as well. Okay, so this looks nicer. So what I would like to do now is clean this up here a bit, and also clean this up here a bit. And the nicest, or the most important part for me would be to clean up this huge lambda here in the option map, because this is really hard to understand at first glance. So the first thing I'd like to have is to have a clean update function. So the first thing is I would really get rid of all of this, and I would just say, okay, in case of state running and the clicked index, I want to have just the state, maybe you make it in the same line, the state with handled click on the index. So that makes it really easy to read. It's really declarative. So we don't know exactly how a handled click looks like, but we just say, okay, we want to have to return the state with the handled click on an index. So make this here also private. And then we try to build this let with handled click on index. And of course we get the state as the last parameter in there. So now we have this huge thing still in there, but our update function looks nicer. So we can do the same thing with this one here. So in here we just say state, oh my goodness, with added number. And then we can also create this new function that with added number state. And we can also re-indent all this stuff, yeah. So if you would stop here, I think we've already added a lot of value or readability, because as you can see now, our update function got much smaller, and then we can just see all the cases that are actually available in our system. We have not started, and we can start it. If it's finished, we can restart it. If it's not started or finished, we can have that the message that the game was actually started, and then we see, we take the initialized game, we put it into running, say without commands, and then if it's running and we clicked on something, we say, okay, we just take the state with the handled click on an index. And if it's running and we get a new number into there, we have the state with the added number. So this is much nicer to understand what the program is actually doing. So, but let's see if we can actually clean this up here also a bit. So the first thing I would like to do is to take this one here out, because this is just a huge lambda that I don't think we really need. So let's take this out, and then we can make a imperative named function here, for example, handle click on, because we really want to do this in there. And then we put the state in there, of course, and we get the click on a specific number. And if we do this, we can get rid of this lambda here as well. And this one here, can re-indent this, which I'm a big fan of, not going too much to the right. And then we can actually say, okay, option map, handle, click on. So, and then we have the state partially applied. And then if we actually find a number, we can use this function, handle click on. So we have also cleaned this up here a bit, so we don't have this huge number. And if we want to go into the logic of the game now, we only need to actually work with this. Of course, let me just think. Okay, we also have the index in there. So let's do this. So it's not only taking the state, but it's also taking the index, put it wherever you like. And then this should work, because we need to call the remove index function, which was somewhere up here, which we can also make private for now. Nice. Okay, so we have now this handle click on function. So let's see. What I really don't like in this function is actually this one here, because it's a big if and else if that I would really like to get out of this. And let's see. What I would like to do is to have something like this. Match the state with, and then we can have maybe a case that says something like clicked or added exactly exactly 10. This is our first thing. So, and in this case, we are having this here. And the other case would be, for example, list too long or clicked too many, clicked too many. We could argue about the names in here, which is then finished game. And maybe something like still good. I'm really getting tired. Maybe the name is not the best, but I hope you get my idea. Is in those cases, we see that we have this without commands. So then we can get rid of this. But the question is now, how do we get this? I mean, it would be nice if we actually had this, right? We just say, okay, we match the state, and if we added exactly 10, then we have those things. And if we have clicked too many, then it's finished. And if it's still good, well, then we can just keep running. And the nice way, and I really like those things in F#, are active patterns. And active patterns are basically discriminated unions on the go. And here we have a function which has basically no name, and the name is, well, it either is added exactly 10, or it is clicked too many, or it is still good. And we get the state in there. And if we're actually doing this, we can then have this in here, and we say, okay, if this is the case, then we say added exactly 10. In the other case, it's click too many. And the last case, it's, well, it's still good, right? And then we need to put a pipe in here to actually make it work. And then, of course, we have the state here and here. And we have the private one. So, and what I really like about this is that now I got a parcel. 1 second. Ha! My shoes just arrived here. If you want to have a look at those shoes, just watch till the end. Okay, so what did I say? Oh, yes. Now that we have done this and used those active patterns in here, then a really nice thing for me is that we have split up the logic, the actual logic in here. So when some rules are applying, and we have split this from what should we actually do when those rules apply. And I really like those this kind of separation in there. So let's see if actually everything works out. So we have the numbers 1, 8. So we put 8, 1. Waiting for another one. Please come in there. No one. Oh, okay. We lost. Again, not clicking too early now. Let's see. We have the 7 and the 3. 6, 3, 1. 7, 3. And we lost. So we have a bug. Okay, let's have a look at let's have a look down here. So we have the 4, 3, 3, which is good, but the clicked is still in there. Have you seen this? 1, 1, 6. So we are already done, and now if I click on the next, now it's cleared. So what did we do wrong? Okay, what did we do wrong? Yeah, we didn't match here over the new state, of course. we just matched over the old state. So let's see it again. We have the 7, 5, 8, come on, come on, come on, come on, 7 and 3, and then the click was empty. This looked much better. Let's see if this, yeah, this looks pretty good. Okay, nice. So I think that's it. There's still some room for more improvement, of course, but I really like this much better now. The update function is really small. The handle click on function also doesn't have the big lumber in here, so you can really read from top to bottom what is actually happening in there. And we also have separated the game logic from the things to do when some things in the game logic actually applying. So if you'd like some homework or if you're interested just to play with this a bit, you could use the same thing with added numbers. So you could also make an active pattern for this if you'd like to. It's also the case. So if you have, I'll look at this one here again. So I didn't have a nice starting page where the rules are actually explained, but you can do this if you'd like to. I think this shouldn't be the biggest thing. One thing that is different here is that the score is always shown. We have our debug thing, so this is not the thing, but let's see if I start this here and then I lose. I have something like a high score. So if I play again now, the high score is always stored in our application state, which we have not talked about now. So this is something really nice I think you could build into. I think it's also, let me just check. I go 5, 8, yeah. So the high score is even retained when I reload the page, which means I guess Ryan used some local storage in here. So implementing a high score would be really nice, I think, and implementing a high score with local storage would be even nicer. So if you're up to this and you watched until now, would be a pretty cool homework, I guess. But apart from this, I think we've reached quite a lot in maybe 1.5 hours. Built a game from scratch with some bugs in there. As I said, if I would build a production thing, of course, it would look different. The whole process would look different. But I hope you had, I was able to give you some ideas how to actually build something with Elmish applications. All right, that's it. This was quite a long video, but I think we got something nice in the end. And if you like this, give me a subscribe and a like and a comment. So if you have any topics you want to discuss with me, anything you want to ask me, would be pretty happy about it. As I just said, I got this nice parcel. So this will be my first unboxing video on YouTube. So I'm going to be famous pretty soon, I guess. So these are my new shoes. I just put my address, put a finger above my address, you know. So Senmodic shoes. I really like those shoes. It's a German company. They handcraft them or handmade them. So I'm going to show you my new white. I never had them in white. This is how they look like. Where is this? Here. Put this thing off. I think they look pretty nice. I like them. I have them in black and in winter style. Barefoot shoes. Really nice stuff. So Senmodic, I can recommend them. Really nice. And I got them in a sale, so they're cheaper as they normally are because they're pretty expensive. Anyway, I'm not going to get famous with this, I know. So that's it. I really hope to see you soon. Bye-bye.